Hello GCC Chem 130 students. We are now on chapter 3. This is a chapter that has math in it. So grab your calculator, I hope you have one. And we're going to do metric units and conversions. Now, I'm recording this from home because I'm recording this during the stay-at-home order for COVID-19. So you may be taking an online class. We may be back to face-to-face, but at any rate, I'm glad you're here to learn about Chapter 3 with me. So let's get started. We need to know about the metric system. Now, if you grew up in this country, the United States, you may have had limited exposure to the metric system. So let's talk about the base units right now. So in the metric system, everything is like a decimal system, and we use the following basic units. For distance or length, the basic unit is a meter. A meter is a little bit longer than a yard. They're not the same. A yard and a meter are not the same. A meter is a little bit longer than a yard. The meter is symbolized with a lowercase m. Mass is measured in grams. Now, a gram isn't a whole lot. It's nothing close to a pound. A gram is about the weight of a paper clip, so it's actually really small. If we're going to weigh a person, then we use kilograms. But the base unit is gram, and it's a lowercase g. Volume, or how much space something takes, like this liquid in this cup, is measured in liters. Liters, it's a capital L, print L, because if you did a lowercase l, it looks like the number 1. So make sure you draw a capital L for liters. Time, luckily, is the same. The base unit is the second. And in all countries around the world, we do seconds and hours and minutes and days, years. That's the same, thank goodness. The abbreviation for a second is simply a lowercase print s. Now, if you want to be bigger or smaller than the basic unit, then we have prefixes that represent powers of 10. So they're pretty easy to convert back and forth between. We're going to learn 5 prefixes. That's not all of them by any means. And we're only going to do one that's bigger than the basic unit, and that is kilo. Kilo is the symbol K, and it's 1,000 times larger than the base unit. So a kilometer is 1,000 times bigger than a meter. In other words, it takes 1,000 meters to make a kilometer. Now, the rest of our prefixes are going to be smaller than the base unit. Deci, D, is 10 times smaller. So I remember that by a dime. A dime is 10 cents, 10 times smaller. So deci is smaller than the base unit. It takes 10 decimeters to make up 1 meter. Deci is smaller, so you need 10 of them to equal a meter. Centa is smaller still. It's 100 times smaller. This is easy to remember because there's 100 cents in a dollar, centa. So centa is 100 times smaller, meaning there's 100 centimeters in the big meter, 100 little centimeters in the big meter. Cent is used a lot. Next is milli, M, 1,000 times smaller. So there's 1,000 milliliters in a liter. There's 1,000 millimeters in a meter. Milli is little, 1,000 times smaller. We use milli a lot. Finally, micro, with the symbol mu. It's a Greek letter. It looks like a U, but you kind of upsweep into that U. And it's 1,000,000 times smaller. I remember that like microscope is to see really small things, 1,000,000 times smaller. So there's 1,000 micrometers in a meter. A million micrometers in 1 meter. Micro goes with 1,000,000. Now, this is not what I want you to memorize, however. I want you to memorize this. We're going to fill in the blanks for these 5 blanks, and I want you to memorize these. A meter, based on what we just learned, is how many centimeters? Centa? Cents in a dollar? Hope you said 100. You're right. A meter is 100 centimeters. Next, a meter is how many decimeters? Deci. Like a dime. 10. Yeah, a meter is 10 decimeters. Good job. Now here's the weird one. A kilometer is big, so there's only one of those. A big kilometer contains how many of the base unit meter? A kilometer is how many meters? You're correct if you said 1,000. Good job. Next, a meter is how many micrometers? Remember micro for a microscope? Yes, if you said 1,000,000. A meter is 1,000,000 micrometers. Last one, a meter is how many millimeters? Yes, if you said 1,000. Now, these are what I want you to memorize. These 5 things. Memorize them. Put a big star next to this. Write it down. Circle it in your chapter. Put it in your notes. Memorize these. So again, hints. Centa, like 100 cents in a dollar. Dessa, there's 10 dimes in a dollar. Milla, like a millipede, they have 1,000 legs, right? Millipede. Micro for the microscope, very small. Now, here's the kicker. I could replace meter with liter or grams, and you have the same 5 relationships. For example, a liter is 100 centiliters. A liter is 10 deciliters. A kiloliter is 1,000 liters, etc. Or I could replace it with grams. A gram is 100 centigrams. A gram is 10 decigrams. A kilogram is 1,000 grams, and so forth. So if you memorize these 5, you've got all your metric conversions for meters, liters, and grams. Cool. So we're going to do conversions with these metric prefixes using the factor label method, which I'm not going to go over everything on the slide, but factor label method basically says figure out what you want to find in that unit, figure out what you're starting with. That's the given, the given. You're going to multiply the given by conversion factors, which means a number over another number, like 100 centimeters over 1 meter, depending on how you want the units to cancel out. Units always cancel out from top to bottom. So if we start with centimeters in the given, on the bottom, we need centimeters in the first conversion factor. Remember, never, never, never start with a conversion factor. Never start 100 centimeters in a meter. Don't start with that. That comes second or third or fourth. It's a conversion factor. Start with the given. Now, for face-to-face classes and papers you're turning in and exams and quizzes that are written on paper, you need to show your work, each step, for full points in this class. If your setup is correct, you'll get partial credit, even if your answer is wrong. So always show all your work. Okay? Now, if this is an online class, we get pretty creative how we ask our questions, but the questions will be about the setup, like, what is the given? What is the first conversion factor? What is the second conversion factor? It's not just going to be asking for the answer. So, because you might can Google that. So we get creative in the online class. So you need to know how to show all your work each step, even for the online class. Let's try a couple of practice problems with the metric system. Number 1, how many liters are in 2,389 milliliters? Okay, start with what's given. It's what we know. We know 2,389 milliliters. That's what we know. Now, where are we trying to get to? We're trying to get to liters. Do we know a relationship between milliliters and liters? Why, yes, we do. Which is bigger, the liter or the milliliter? The liter is bigger, milliliter is smaller. How many milliliters are in the liter? Milla? 1,000. There's 1,000 milliliters per liter. Per means divided by. 1,000 milliliters per liter, or a liter per 1,000 milliliters. So we're going to set up a fraction next. It's called a conversion factor. What we start with needs to be on the bottom. So the 1,000 milliliters is on the bottom, the 1 liter is on top. And it looks like that. Okay, so parentheses with a line through it. That's our conversion factor. Notice milliliters will cancel out from top to bottom. We're now in liters. Is liters what we're looking for? Yes, how many liters? So we're actually done. So all we have to do is punch this into our calculator. 2,389. Now the number on top is times, so times 1, which really doesn't change anything, so you don't have to do times 1. The number on bottom means divided by, so divided by 1,000 equals 2.389. Unit, liters. Good job. Let's pay attention to sig figs because we're multiplying, so it depends on sig figs. 2,389 has 4 sig figs. 1 liter over 1,000 milliliters is exact. Remember in chapter 2 when we talked about exact numbers being definitions? So there's exactly 1,000 milliliters in a liter. That's exact. Exact numbers do not count for sig figs. So you don't say that's 1 sig fig. It's actually an infinite number of sig figs because it's exact. It's 1.00002 infinity liters over 1,000.0002 infinity milliliters. So there's actually a lot of sig figs. So the least amount of sig figs is the first number, the given 4. 4 sig figs, our answer has 4, it does. We're good. We started with 4 sig figs, we ended with 4 sig figs because our conversion is exact and doesn't count for sig figs. Cool, that's our first conversion, and it was a metric conversion. Good job. A lot of explanations there. Whew. Let's try one more. How many kilometers are in 12,300 centimeters? Start with what we're given, which is what we know. 12,300 centimeters. Okay, we need a conversion factor. So parentheses with a line through it. What's on the bottom? Centimeters is on the bottom. What goes with centa? 100. So 100 centimeters is in the bottom. 100 centimeters is what? 1 meter, right? There's 100 centimeters in the meter. 100 little centimeters in a meter. So that's our first conversion factor with the 100 centimeters on the bottom. 1 meter over 100 centimeters. Okay, so centimeters cancel, we got meters. Is that the answer? No, it asks for kilometers. So we've got another step. Do we know a relationship between meters and kilometers? Yes, we do. Which one's bigger, kilometer or meter? Kilometer is bigger. In fact, it's really long, right? Kilometer is really long. How many meters are in the kilometer? Yeah, 1,000. So we've got 1,000 meters per kilometer. But what needs to be on the bottom to cancel out? The meters. So 1,000 meters is on the bottom with 1 kilometer on top. There we go. Meters cancels out top to bottom. We've got kilometers now. Is that the answer? Yes, it is. So let's grab our calculator. Now there's many different ways you can put this into your calculator. You don't have to do it my way. Here's how I'm going to do it. 12300 times 1 divided by 100. That takes care of the first fraction. Times 1 divided by 1,000. That takes care of the second fraction. Now I hit equals. 0.123 unit kilometers. All right, let's check our sig figs. We're multiplying and dividing, so we focus on sig figs. The beginning number, 12,300 centimeters, has 3 sig figs. The zeros do not count, there's no decimal point. The conversions are exact. There's exactly 100 centimeters in a meter. There's exactly 1,000 meters in a kilometer. So we can ignore those. So the final answer needs to have 3 sig figs, and it does. 0.123 has 3 sig figs, zeros in front don't count. Kilometers is the unit. We're good. All right. Let's stop there and take a break. Catch you on the flip side, GCC. Bye-bye.